Good morning, everyone, and welcome to our webinar where we will be discussing the use of AI in energy management. It's great to have your company and thank you for joining us. So, artificial intelligence has many meanings and manifestations. In the energy setting, we'll discuss what that means for us now and in the future. The webinar experts from HYGRID Energy and Energy Terrain, which I will introduce to you in a moment, will cover what technology is out there and in the pipeline, and where AI can be and has been applied to assist businesses transitioning to renewables. I'm Tiffany Dang, Junior Commercial Manager at Energy Terrain, and I'll be your host for this event, and I'm looking forward to the discussions we will have today. Just some housekeeping measures. You will have the chance to ask questions via the comments section, and we would love to hear what you are all interested in knowing more about. So please feel free to put those in the comment section of the live, and we will be answering those throughout the webinar. We'll also be running a poll in the comments section, and your participation is greatly appreciated. Before we speak to the panelists, why don't we learn a bit more about them? Our first panelist is Geoff Cope, the Director of Energy Terrain. Leading Energy Terrain's sales efforts, he knows the evolving market demands and technologies and helps clients find the best solutions to meet their renewable energy needs. Good morning, Geoff. How are you today?
Good morning, Tiffany. I'm very well today, thank you. Very excited to be here and looking forward to the conversation with everybody. It's an exciting time to be in the renewable space, and particularly this week or in these coming days with the Glasgow conference going on offshore. I think it sort of lays a perfect backdrop to conversations such as this one that we can have today, and looking forward to it. Thank you.
Definitely. And did you want to introduce yourself a little bit? Tell us about what you do at Energy Terrain.
I don't do too much. No, I look after the sales effort at Energy Terrain. So as a director in the business, it's the role that I bring to Energy Terrain is to engage with our prospective and existing clients with the view to understanding what their needs are and helping to position our solution into their world. So I work closely with everyone else, yourself and others in the business, to drive the different strategies that we are undertaking. But day to day, it's about talking to as many prospective customers as I can and maintaining good relations with all our existing customers and suppliers. So that's my involvement.
Awesome. Thank you, Geoff. Looking forward to talking with you today. Now introducing our second panelist, Marc Pelletier, Engineering Director and Founder of HYGRID Energy. Good morning, Marc. How are you?
Good morning. How are you, Tiffany?
I'm good, thank you. So I see you're an electrical engineer with over 15 years experience encompassing a wide range of power systems. Tell us a bit more about that.
Yeah, so I am an electrical engineer. I've spent my whole career in energy. I think it's a really cool industry. I started in Canada as an engineer in a nuclear power station, which was quite exciting. And then I moved over to the Australia-New Zealand region, where I got into transmission, system operations, and spent a lot of time in the energy storage industry as well. I'm one of the co-founders of HYGRID, and I'm really passionate about some of the changes that are coming to the electricity industry. See a big change that's coming due to renewables, and I think a lot of people think that renewables is already here, and they are to some degree, but there's still a massive change that's yet to happen. There's still a lot of base electricity, a lot of coal power, a lot of nuclear power, a lot of energy that we can replace with solar, wind, and other renewable assets. And I think it's a really exciting time to be involved in this transition and in the industry. So I'm really pumped to be part of that transformation.
Awesome. And what is it that you do at HYGRID Energy?
So I'm the engineering director. Generally doing a lot of design. I'm doing a lot of talking with clients, doing a lot of proposals, doing a lot of, generally trying to kind of gain momentum with customers and pushing pushing the rolling the ball, I should say, in terms of getting things done and making things happen, getting people to work together.
Awesome. Thank you, Marc. Looking forward to talking with you today.
Thanks.
And finally, our third panelist, Ben Shepherd, founder and director of HYGRID Energy. Good morning, Ben. How are you?
G'day, Tiffany. I'm great. Thank you. I'm very excited to be here and to be part of this conversation.
Yeah, we're excited to have you. Now, Ben, I can see here you have an impressive 25-year career in commercializing Australian technology in global markets. Tell us a bit about that.
Yeah, I'm a commercialization guy, Tiffany. I've spent my entire career commercializing Australian innovations and technologies, ranging from fintech stuff to cryptography type stuff to, over the last decade, battery energy storage stuff. And it's been an exciting journey to be in the battery energy storage space and the renewables industry more broadly. Just 12 months ago, Marc, who you just met, and our other co-founder, Hamish, and I set up HYGRID Energy because we saw a massive need for better management of energy systems, renewable energy systems, to improve outcomes for customers. And I'm really excited to be on this journey, and I'm looking forward to the conversation.
That's great. And what do you like working about? What do you like working at HYGRID Energy?
Oh, look, we're a tech startup, Tiffany, so it's an absolute roller coaster. It's very exciting, white knuckle biting adventure, but we're doing some awesome things for some awesome customers. I think there's, and it's an important aspect of the great transition to renewables that Marc mentioned, is making sure assets are properly managed effectively over life. And some of the tools we'll talk about today, like machine learning and what have you, play a very important part of that. And that's what we're doing.
Awesome. Thank you, Ben. Looking forward to discussing the use of AI energy management with you. Thank you. And now that we have met all of our panelists, I'd love to get into our discussion. So I want to start this off by understanding the multiple meanings and interpretations of AI, and more importantly, what AI means to us and how it's being applied in the renewable industry today. So Ben, I'd love to hear what you have to say about this.
Yeah, awesome. Thanks. Look, and it's a great question. There's actually a definition from Accenture for AI that I quite like, because it gets to the heart of the challenge that AI means a multitude of different things for different people. I think we could probably put that definition up on the screen. Thank you. Then I don't need to read it out. But fundamentally, AI is about making machines act and behave like humans. Now, at its broadest, that's bringing together a constellation of, I guess, technologies and techniques to try and make self-thinking, perhaps self-feeling, even creative machines. Now, we have a long way to go before machines are fully mimicking humans, and I'm personally not unhappy about that, although it's an extraordinarily exciting field. But I think the important point for us today is that a lot of the AI technologies and techniques can be applied in much narrower circumstances to specific domain areas or specific problems, like energy management. And before we drill into, I guess, energy management, some of the more common examples might be like Google's maps and navigations and traffic prediction tools, which are based on many of these technologies and techniques. Similarly, the automated stock market trading platforms use many of these techniques. In the energy industry, these particular things, and I'll go into a couple of them, machine learning, predictive decision-making, automated problem solving, open up a lot of doors for us. And in this instance, this is quite simple AI, if you like, but it's enabling devices to make smarter decisions than would be possible from a static program or static software. Now, machine learning is where past outcomes contribute to future machine decision-making without having to be reprogrammed. Predictive decision-making is where machine applies forecast and historic data to achieve certain future outcomes. Automated problem solving is where machines make a judgment between an array of options as to which will have the best outcome. Sensing surroundings is where machines can monitor information from their surrounding environment and process it for a particular purpose. And all of these things we can apply to the energy sphere. And maybe before we drill too far into the energy sphere and I depart too far from the question of definitions, I might throw it to Marc, because I think he might have some different views.
Hi. Yeah. Look, I have a slightly different take on it, and my definition is more based on is simply just the Oxford Dictionary definition, and it's the theory of development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, and the big one here is decision making and translation between languages. I think the key one here that we focus on is decision making. But I think a lot of people think of our artificial intelligence as the ability of a machine to learn, and that piece of it is only machine learning. Artificial intelligence, in my opinion, as per the definition I just read, can be a decision making machine that takes many inputs from the internet, from sensors, time of day of week, weather, etc., and makes decisions based on this information. So different, but slightly the same.
And I think that's key to all discussions around AI. Different people will have different views based on what their interest and experience and needs and worldview are, and that's no bad thing.
Awesome. That's really good to hear. So it sounds like lots of different factors go into creating these AIs. So either of you, how complicated would you say implementing these AI solutions are in the renewable energy industry?
In terms of complexity, I might let Marc answer that, but maybe it's worth just identifying some of the areas in the energy industry where these techniques are being used. And I can lob some ideas there if you like. One of them is in energy trading. You have products from Tesla, its AutoBidder product, a company called AMS, Advanced Microgrid Solutions, that have built and continuing to build tools that apply many of these techniques to bidding into energy markets, much like the stock market trading platforms I mentioned before, to enable greater profitability on your energy trades. Similarly, there's vendors like STEM Inc. and Reposit Power. STEM is in the United States and Reposit's here in Australia, who use these kind of tools to dispatch distributed energy assets, or DERs, across the network to achieve certain outcomes. And sometimes that's complex, balancing both market returns and delivering outcomes for the sites where those assets sit. One of the things that Marc mentioned was sensing surroundings, and there's technologies that have been developed by CSIRO here in Australia and by Fulcrum 3D for optical sensing of the sky, of cloud cover, to be able to see cloud movement and cloud thickness and speed and direction, and to be able to make decisions about utilization of solar assets based on that sensing of the surrounds. So there's a lot of different areas where this can play out. Marc, do you want to talk a little bit about the complexity?
Yeah. Look. So I think it's best to kind of just jump into what it is that we're doing at HYGRID and kind of talk about our approach. And so the big one that we're working on is basically working on making decisions now on forecasted elements of the future. And so the big one here is if you have, and the example I'm going to use is a hot water load. If you have a hot water load and you have hot water usage, and you have a solar array on your roof, you have choices to use this solar hot water system at different times of the day. So typically, a solar hot water system will charge, or I guess not charge, but consume energy at off-peak hours. And so those off-peak hours are from 11 to 6 generally. And then there's on-peak hours, which is all other times. And so a hot water system can use off-peak energy, which is at a lower tariff. But solar is, when it's installed on your roof, is a lower tariff again. It's free, right? And so a lot of people export a lot of that energy when they're not using it. And so the problem that we're really trying to solve is making the decision when it is off-peak for the usage for the day. So we look, and so it takes two things that you need to forecast. You have to be able to forecast your solar that you're going to be getting that day, and you need to forecast the load that you're going to be using that day. So you need to get your water to a certain temperature, and you need to make an assumption and make predictions as to what that's going to look like. And so that's the predictive decision making that HYGRID do on a regular basis, and that's kind of the automated problem solving that we're trying to do. And so basically it's what is my expected load versus my expected solar energy. And it's something that I feel humans do naturally, but someone's not going to wake up at 3 a.m. every morning to decide whether to heat their hot water at off-peak by looking at the forecast of weather. And so what we're providing is a means of that control for you. And so we look at the weather. We take in a lot of weather data. We look at a lot of forecast data as well. We look at 48 hours out all the way down to an hour out. And we're making those decisions for you of, okay, I have the option to use off-peak energy today. Is it going to be a cloudy day? If it's going to be a cloudy day, I think I'm going to use that off-peak energy because I don't think I'm going to get enough. Or is it going to be a really sunny day? And so I'm going to actually use perhaps no off-peak energy and just let my son do all that charging for me. And obviously that's just each end of the extreme. And then there's the middle, which is a little bit of off-peak, a little bit of solar. And so those are the kinds of decisions that we're making using our controller. And so it has to sense the surroundings. It needs to take in a lot of inputs. It's looking at the weather. It's looking at the load that the customer uses. It's looking at the time of day of the week. There's energy meters, irradiance forecasts, and weather forecasts as well. So there's a lot of info that's being pumped into our system, and what's important is how you use it. And so we then can further improve that decision making. So I can make an assumption about load and what it's going to do in that day, and say, okay, I think they're going to use this much energy. But what machine learning can do to help us is try to improve that assumption on the load usage that day to better match the decision making earlier in the day. And so it's the same thing with the solar irradiance forecast. We have a forecast that's coming in, but nothing's ever perfect, right? And so it's about using machine learning to apply it to all these inputs that we're taking in, and you have essentially you have a forecast that you're doing every day, but you also have an outcome. And so you're comparing your outcomes to your forecast, and you're pumping these all in, and then you're hoping that your algorithm gets smarter and smarter and making better and better decisions.
Thank you for that really in-depth response, Marc. And at this point, I'd also like to remind the audience that we can take questions. Perhaps there is something that's already been mentioned that you'd like the speakers to provide more information on, or you have any other questions, feel free to ask them in the comments section. We'd love to hear from you. Looks like we've got one from Durand. He's asking, what problem are you trying to get the machine learning to solve?
Look, very, very, very succinctly to kind of summarize what Marc was describing in depth. We're using machine learning to solve for the lowest cost of energy and the optimized utilization of assets, or whatever particular outcome a customer is seeking. But very typically, it's the lowest cost of energy from all the available sources.
Awesome. Thank you. And Geoff, we'd like to hear from you as well.
Actually going to just chime in and add on top of Ben's remarks there in response to Duran's question. I think from the clients I speak to regularly around, integrating solar into their businesses, I think the problem that we're trying to address with the use of the controller, the AI controller that Marc and Ben have discussed, is the how do I better utilize my assets to achieve an outcome which could be cost related, but also renewable related, because increasingly there is an appetite in the market to say, I've got a roof, I want to use more of that roof to to have greater control over how much of my energy is definitely renewable. And if I can, maximize the roof cover of solar and reduce the amount of grid power I draw, that there is the challenge, which is kind of in the black box that the AI controller is actually assisting me to do. So that's the sales take on it, I guess, Ben.
Perfect.
Alrighty. And now that we've talked about the meaning of AI and more specifically what it means in this context and the AI techniques which are being applied in the renewable industry today, I'd like to hear from all of you for this next question. But first, Marc, would you like to let us know what this means for customers and businesses transitioning to renewables?
Yeah, sure. I guess to me, the biggest issue with renewables is they're unreliable. You don't, whether it's wind or solar, you don't know when it's going to, wind's going to blow or the sun's going to shine. And what might be a clear day in the morning doesn't necessarily mean it's going to be a clear day in the afternoon. And I also think that customers want renewables because they provide a cheaper alternative, and they're also a green alternative to purchasing power from the grid. And so I think, customers are well-intentioned, but I also don't think that they want to think about turning on their hot water heaters at 3 a.m. in the morning, based on a weather forecast. And so, I think what we're providing is a method of gaining some of that control back. And it's a means to ameliorate the problems, as I just mentioned, in tandem with proper sizing and good design of the system, and having smart inputs and looking at all the right variables that you need to make these, to make best use of your renewable assets. I guess I'd like to hear what Geoff has to say in terms of, customers transitioning from a PPA point of view.
Yeah, I think it's the types of challenges I think that we're addressing with these solutions in our customers' eyes come from a range of different perspectives. But one view is that we've got businesses out there today who are consuming power in a pattern which has been derived from the market situation that existed when that pattern was commenced. And what I mean by that is that once upon a time, all power came from a centrally generated location, and it was distributed through the grid. So your only choice to have power was out through the grid. And in that setting, there were times of day and times of week where there was surplus amounts of energy being produced that that could be consumed. And that was the kind of the origins of the off-peak power tariff, alternate tariffs, if you like, that exist in the market. On the consumption side of that setting was then behaviour that sort of followed that said that I've got things that can be done. I've got power load rather that can be used or aligned to where that off-peak power exists. So to Marc's example of the hot water being directed to the off-peak, there's a binary decision there that says, well, it's peak power, we don't heat. If it's off-peak power, we do heat. So that type of supply conundrum or supply environment dictated how businesses were starting to use power and set up their processes. So wind the clock forward to 2021, technology has changed. The generation of power is done in a range of different locations around the grid, and not least of all can be done behind the meter at the premise where the power is being consumed. So rather than being a relatively straightforward binary off-peak or peak supply based on a clock, you now have a situation where any time of the day there is a much more dynamic decision to be made about how to power the supply the energy into the load that I have. There's a dynamic moment being presented all the time to make best decisions about I guess the point that Ben was making earlier about that kind of making the best decision to source the lowest cost of power at any moment in the day, as opposed to the older way of doing things. And I guess the extension of that also then leads to the fact where businesses can now start to think about, well, what is the optimal process structure for my business to work, as opposed to fitting my processes into when energy is cheapest. Now I actually have more flexibility about how I structure my operations, because I'm no longer constrained by just having a peak and off-peak type model. And I think they're in a large-scale industrial setting or in a smaller scale commercial setting, those types of challenges and opportunities exist for the clients that we're talking to today.
I agree with that, Geoff, absolutely. And I think one of the things to draw out there and where machine learning becomes really beneficial in this environment, and the predictive stuff becomes really beneficial in this, is how businesses change their utilization according to things like day of the week or seasonality. And as a system runs, it can gather a whole lot of data around that, and it can moderate the systems accordingly to achieve that outcome of the lowest cost of energy or maximum utilization of low carbon sources, or whatever the customer's ultimate goal is. And I think that then just comes around to the question that Tiffany asked of what does it mean for a customer, and what it means for a customer is fundamentally better outcomes for your energy system. And primarily that's driven by energy costs, but to your earlier point, Geoff, not necessarily. There's some other factors in there.
Alrighty, that's really awesome to hear. So if I was a business or a customer, how would I know if these solutions are suitable for me, and how do I know if they can be integrated with my current system?
Do you want me to grab that one?
Look, I think the sales answer to that is please come and talk to us. I think there's probably a good technical answer there. Marc, why don't you?
Sure, no problem. Yeah, look, it's a very fair question. I think it's, like Ben said, do engage us. But if you have any sort of loads that are flexible, such as hot water or heating, cooling, those kinds of loads, which in some other cases it's just moving things from one end to the other, or perhaps it's even just milling grain, something that you don't always have to do at a specific moment in time, and it's flexible. Maybe you can flex it left or right by an hour or a day or by an amount. That allows you then to take advantage of solar when it is when the sun is shining, essentially. And so, yeah, I would say any sort of flexible loads that can be shifted is a great place to start. And in terms of integrating, it's then just a question of doing a bit of design and having a look at the system.
I think that's a really good point you touch on there, Marc, is that there are maybe hidden within businesses, there are a whole bunch of battery surrogates that exist that maybe we don't know about today. And I know some of the work we've been doing in the intensive agricultural space highlighted where, water tanks, for example, can be a battery surrogate in a client site we have in South Australia, where they use the renewable energy for a desalination plant. So the water tank, they've got a bore running to lift the dirty water from the bore. That's one tank. They've got other tanks on the other side of the desal plant where it's clean water. So having the control of being able to sense both the capacity available within those tanks at any moment and the ability to engage both the pump for the bore tank and also the desal plant for the clean water tank. When the conditions are right, i.e. there's surplus solar energy being produced at any one time, that they can make a decision to run the pump when the power's there, as opposed to maybe being on a timer to run 3 hours a day at 3 a.m. in the morning, for example.
Yeah, and the other one there is you can also add a bigger tank, and you essentially have a bigger energy storage system to take advantage when it's advantageous.
That's right. And so I guess the point there, from a customer's point of view, Tiffany, or prospective customers, to think about what are the processes or steps in the process which are, maybe hiding the fact that they can store power that's available for use at the time it's available, as opposed to being locked into running those processes at a particular time.
Yes, thank you for that. And now let's have a look and see how many, if we have any questions from the audience. So it looks like we've got one from Andrea. As we only know how much a customer exports, how do we make an assumption on the solar capacity installed in the premises? Who'd like to take this one on?
Well, one of the things, in the solar PPA world, Tiffany, is to understand the annual load of a business, and then to apply a rigor that says that, we try to keep, circa 80% of the power generated from any system on the premise over the course of that year. So that takes into account seasonal use of power, takes into account, the weekly cycle of the business, takes into account the daily cycle of the business. And, I think it's one of the pitfalls potentially that exists around commercial solar adoption is the big roof pitfall, i.e. I've got a big roof, let's fill it with solar and generate as much power as I can. But the trap that comes with that is that if you then start to export bulk amounts of power at different times of the day, week or year, the economics of having all that surplus power causes you some heartache. Where I think the AI component applies to this type of question and the size of the system that you would require is that it introduces a more dynamic approach to how that energy is used across the year. So therefore, you may, rather than striving for an 80% retention of power generated on the roof to be used under the roof, you can have a higher aspiration of increasing that 80 to maybe 90 or higher, again, with the adage that the more you can keep on site, the more economically viable and rewarding it will be.
Yeah, that's exactly right, Geoff. And the machine learning tools that Marc was describing before are perfectly suited to doing that, from accumulating what's happened in the past to inform the automated decision making going forward.
Yeah.
Alrighty, thank you for that. And looks like we've got another question from Paul. So is HYGRID offering aggregation or retail services to the end user, customer, as well as an AI solution?
Look, we're a technology platform, Paul. We're not in the business of being an aggregator, but we can provide the technology behind the commercial aggregation service. If I think I understand if I'm understanding your question correctly.
Alrighty. And now I'd also like to hear from Geoff regarding the role of energy terrain and solar power purchase agreement pricing. How are these AI solutions impacting solar PPAs?
Yeah, thanks, Tiffany. I think the much of the conversation around the solar power purchase agreements and how they work in any setting, but more importantly, in today's conversation around how it is impacted by the use of the artificial intelligence decisioning, it goes to the heart of the point I was touching on a moment ago, where the ability to increase the amount, maximise the design size of the generation system firstly, whilst keeping in mind or keeping a rein on how much of the generated power is actually exported into the grid. So that's the, if you like, on the design and proposition side of the equation that we tackle with the HYGRID partnership and with the use of AI. From a more pragmatic and economically focused answer, I would say that a PPA is perfectly flexible from in its ability to package into it whatever costs need to be associated with the solution for the purposes of an ease of operation of a power purchase agreement. So what I mean by that is to say that if there is an additional charge in the setup cost structure to incorporate a HYGRID or an AI solution to maximise the on-site use of the energy, then that capital cost can also be incorporated into the power purchase agreement structure. So the benefits of a PPA, or one of the key benefits of a PPA, is there's no upfront capital required by the customer. So any kind of cost associated with those features that we've discussed already can be part of the cents per kilowatt hour rate going forward, and or not. So, there is flexibility in how that can be applied and utilised.
Awesome. Thank you, Geoff. And I'd like to know how HYGRID Energy fits into this process as well.
From my point of view, I'm going to say that HYGRID Energy fit into this process because they're a partner of Energy Terrain in this regard. So we come across, on a frequent basis, a bunch of clients who have the potential for a larger array than what the initial design warrants. And that's where I guess we turn to the likes of Marc and Ben to help us understand what is the larger capacity of that particular site when you take into account all the factors that we talked about before in relation to the business processes happening under the roof, but also the dynamics of how we would structure a controller with or without battery storage under the roof. Happy for...
I couldn't have said that better, Geoff. Fundamentally, we're a technology partner in this. So we can help understand some of those challenges and complexities within the customer's business, and how better energy management tools can be applied to achieve those better outcomes. And then we can follow through on that by delivering the control solutions and technology that delivers on those expectations, with the tools that will continue to improve over time by using these machine learnings and predictive control techniques.
Yeah, I also think it's worth noting that solar now is not at a point that it's less expensive than off-peak energy. And so people that have a high off-peak load are now they obviously cannot utilize solar for their business. And so that's where we can help customers who don't have that solar load profile to move those loads into a time when it's more advantageous.
Awesome, thank you. And we also have a poll, and I think we should launch it. So in the comments section, if Stephen Backstage could please post the question in the chat, what do you see as the greatest opportunity for improvement in your energy systems from the use of AI techniques? Number 1, energy trading. Number 2, intelligent control and optimizing for heating and cooling. Number 3, minimizing the degradation of panels and batteries. 4, environmental sensing and rapid response to changing conditions. 5, lowering the operational costs and operational downtime, or optimizing for feed-in tariff. So if everyone would love for you to participate, comment which one you would like to vote for, and we'll tally them up at the end. Alrighty, and looks like we've got another question for the panelists from Noel. Would the decision-making be done locally? If not, will internet outages affect operation?
Good question. That's a very good question, though. I do have an answer for that. So internet is an issue for a lot of customers, but we do have a controller which does sit on site and can make decisions when the internet is not available. And so it will be on a case-by-case basis. But if there is no, in the hot water case, if there is no internet available, we don't have any sort of forecasts, you just revert back to the standard model of using off-peak energy because you don't have any information on the forecast that's coming in. And so the controller is smart enough to say, I don't have any internet, I'm not going to make a smart decision. That's probably going to cost the customer money, so I'm just going to use off-peak tariff instead.
Yeah, that's a great question, Noel. We've just done a project in rural Western Australia where connectivity is quite poor and sophisticated control is required. And the technology that we've put at that site enables the system to operate without fully effectively without external internet feeds. But when those internet feeds are available, it enhances the decision-making capacity on the at the site.
Alrighty, that's really good to hear. Thanks, guys. And now that we have learnt what AI means for customers and businesses transitioning to renewables, what industry sectors are best suited to AI power management? Maybe we'll start with Geoff.
Thanks, Tiffany. I think there's the broad introduction I would put to that is that any industry sector that has a relatively high in-day, in-week energy load that has components within it which are flexible as to when they would work. So we've already discussed or been mentioned in conversation today about the intensive agricultural space, so dairy in particular, pig farming is another one. The contrast in that kind of realm would be the likes of chicken farming and intensive housed agriculture, where you have a rotation of maybe 6 or 8 weeks of relatively intensive energy use, and then 2 or 3 or 4 weeks where there's very low energy use. So in those settings, in that subset, if you like, of intensive agriculture, it doesn't work as well. But broadly speaking, that any industry or any business that has got a high energy use, energy load, but where has flexibility in when that load is applied, that industry or those businesses would be well suited. Manufacturing fits in there, but again, as a blanket remark, manufacturing probably is not a catch-all, but within the manufacturing umbrella, there will be subsets of those businesses that do fit that criteria of having capacity within their business to actually have load moved around to suit when the power is available from the roof. And then you've also got things like food processing, you've got commercial kitchen operations, you've got hospitality. Whilst, again, as blanket remarks or blanket grabs at a sector, they probably are not well suited. But within those, those industry areas, you will find subsets of those operations which are very well suited to this type of dynamic decisioning to enhance its use of renewable energy. How about you, Marc? Do you agree, or have you got a contentious view for me?
Yeah, no, I largely agree. I think other opportunities is just apartment buildings that have a shared hot water system or a shared HVAC system. Another opportunity would be large swimming pools. That's a big swimming pool is a massive battery sitting inside a building, and they need to heat that water for their customers, and that's just an opportunity to shift that renewable energy into that asset.
Awesome, thank you. And does Ben want to add anything as well?
Yeah, sure. Look, I think you guys have covered it quite well. I think the observation that I would make is that it's less industry specific than business specific. So within industries, there will be subgroups that where this is very useful, and others where it might not be so useful. And that goes back to Geoff's kind of list of variables that make for a suitable target. So load variability, a potential to defer loads, potential to use low tariff energy if solar forecast is poor, and the opportunity to store energy, whether in the form of a battery or hot water or some other thing. So it's maybe not blanket per industry, but there's lots of, I guess, subsets where that's useful. In addition to the apartment complexes, Marc mentioned commercial property has often shared heating and shared cooling and hot water. They're great targets. Industrial laundry is very specialized, but those kind of characteristics apply. So I'd be thinking of it in terms of what kind of characteristics does my business or do my customer's business have, and to assess whether this is appropriate or not, rather than thinking in terms of a particular industry vertical.
Alrighty, thank you. And what about the future? What's coming down the pipeline?
Well, more renewables are coming down the pipeline. We are at a point, a transition that's been discussed at nausea by ourselves and in more broader commentary in the marketplace. But there'll be more renewables coming. There are more coming. I think the interesting element to that, to my mind, when I think about businesses that I speak to, is the sense that no longer is there the reliance on one source of power going to dominate, and having a blended power supply structure for their businesses will be what happens more and more into the future. So, yep, they'll buy some from the grid, but they'll be sourcing it from their own rooftops, and in certain settings there'll be microgrids and other types of energy generation capacity around those businesses as well. So blended energy supply and more renewables.
Yeah, and look, from a technologist, with my technologist's hat on, I think that this the massive growth of renewables, and as we progress through this great transition of our time, there's more and more opportunity for great technologies to be developed to enhance outcomes. And what we're doing is just a tiny little part of that. I mean, the stuff that, the companies that I mentioned at the outset who are doing energy trading and DER management and optical sensing and all of this stuff, there's so much room for innovation in the energy space today. It's a really exciting time. We've got the privilege of being involved in a clean tech accelerator program, and the other innovative clean tech startups that are around today it's so exciting. We are living in a great moment.
Alrighty, thank you. So we are nearing the end of today's webinar. So if anyone has any final questions, please send them through. Otherwise, I'd like to get one closing statement or sentence from each of you. We'll start. Geoff, would you like to kick us off?
Yeah, if you have any inquiries about solar PPAs, just give me a call. No, in seriousness, I do think that we are looking at an exciting 12, 18 months as we come out of this lockdown world that we've been in, a bit more certainty about how business will operate. And we're here to help reduce both carbon footprints and operational expenses.
Alrighty, and Marc?
Yeah, I think there's a lot of opportunity out there for people to make better usage of renewables using a bit of intelligence, and we're really keen to enable that. The traditional grid model is really been thrown on its head, and it's painful for some, but advantageous to others. And I think it's just about being conscious of it and talking to someone that could perhaps give you a hand.
And Ben.
Look, I've just really enjoyed the discussion. Thank you very much for including HYGRID energy in it. I think this is such an exciting space, and we're really excited to be on our journey, and we look forward to continuing working with Energy Terrain. It's a great privilege.
Awesome, thank you. And looks like we've got one more question from Durand. Is the energy market geographically restricted? How much energy do you lose as you buy it from a power source further away?
So whenever a customer is buying energy, it's from their energy meter, and so they would not have incurred those losses. But if that generation station is hundreds of kilometers away, there would have been losses in those electricity lines. And it can get quite high. But as an end user, that generally would not affect an end user. Yeah.
There are technologies becoming more and more prevalent that use crypto techniques to allow the virtual signing of a unit of electricity generated over here that's used over here, which is very novel and exciting and stuff. But fundamentally, in very real and practical in terms of electron flows, yes, I guess that the utilization is restricted, but the market has opportunities to overcome that. So.
Awesome, thanks guys. And if anyone has any further questions, please feel free to reach out to our panelists. Stephen, can you please bring up the contact us slide? So if anyone wants to contact Energy Terrain, you can call 1300 814 845 or email info@energyterrain.com. If you'd like to speak to HYGRID Energy, please email solutions@hygrid.energy. All the information is available on the screen and will be made available to you at the end of the webinar. I think we can go over the poll results now. So it looks like, for our question, what do you see as the greatest opportunity for improvement in your energy systems from the use of AI techniques? Number 5, environmental sensing and rapid response to changing conditions seem to be quite popular, alongside intelligent control optimizing for heating and cooling, as well as number 6, lowering the operational costs and operational downtime. Any final comments on that, guys? On our poll results?
Not from me, no.
It's interesting. So thank you. Thanks for responding.
Yeah.
And it looks like we've got a question from Nanditha. What feasible measures would you opt in understanding the degradation of panels and batteries when applying ML and AI?
That's a question that someone must have been reading our website. The three of us, the co-founders of HYGRID Energy, actually have spent a lot of time in the battery energy storage space. And while our vision is much bigger than batteries, obviously, one of the things that we came to this understanding is that battery degradation is something that's really important to the performance of assets over life, and that we have some pretty thorough, in-depth understanding of how batteries degrade. And we are, as part of our AI techniques, we're using battery degradation metrics to feed into that decision making. So yeah, great question. Thank you.
Alrighty, I think we'll wrap up unless if anyone else has any final questions. All right. So thank you very much to our panelists for your answers and the time you put into answering these and providing the information. I know I have definitely learnt a lot, and I hope everybody out there watching has as well. The information and recording of this webinar will be made available on Energy Terrain's YouTube, Instagram TV and website. And you can also always contact us and HYGRID Energy as well for any further questions. That's all from us. It's been great, and thank you all for joining us.
Thank you very much.
Thanks, Tiffany.
Thanks, guys.